Welcome to OpenShift Anywhere with F5 Distributed Cloud How-To Video Series. In this demo, we'll cover Module 3, F5 Distributed Cloud Mesh to secure Red Hat OpenShift Cloud Services. In the last two modules, we demonstrated how quick and easy it is to use F5 Distributed Cloud to discover services for Azure and AWS respectively, and make OpenShift services available in any location, be it public cloud, private cloud, or the edge. This means applications are no longer constrained to a single provider. As a result, this presents a couple of challenges. First, ensuring that applications are protected regardless of their location becomes an increasing challenge. And for every provider, disparate tools, it's very difficult to find a solution that is effective at handling all application demands. Secondly, this has led to a significant increase in the attack surface. Attackers have many more options when it comes to modern apps, not just exposing corrupted app code, but also APIs, growing user bases, more exposed infrastructure. To address those security challenges, F5 Distributed Cloud Web Application and API Protection, or WAAP for short, provides a SaaS-based approach to application security that protects each application's attack surface, namely WAF, bot and fraud mitigation, application-based DOS protection, and API protection. At the very core, we have the Web Application Firewall, which is based on our F5 BigIP Advanced WAF engine. First, let's look at the demo scenario. We have two different web apps running in the clouds. Both applications are proxying traffic through the F5 Distributed Cloud SaaS platform. Both of those applications need to be secured. In this demo, we will showcase how quick and easy we can use F5 Distributed Cloud to deploy, manage, and enforce security policies across the distributed workloads. We will do this through three simple steps. First, we'll create a web application firewall. Next, we'll attach the newly created application firewall to the existing load balancer. Then we'll test our WAF through some simple attacks. And finally, we'll explore some of the visibility and security insights provided by the F5 Distributed Cloud dashboard. Let's dive in. We are starting off by taking a quick look at the applications. Showing here two different web applications. One is called Hipster Shop, deployed in Azure Red Hat OpenShift. The second app is DVWA, which is deployed in the Red Hat OpenShift on AWS. So we go ahead to simulate a couple of simple OWASP top 10 attacks, just for demonstration purpose. First, with the command injection, the goal is to execute arbitrary commands on the application host. Then we executing stored cross-site scripting attack. We are injecting script, and the injected script is permanently stored on the target application or in the database. So these are just simple attacks. A skilled attacker will use multiple tools to explore various attack vectors. The point I'm trying to make here is our applications are exposed without protection. Moving on, let's see how easy it is to create an application firewall and apply a uniform WAF policy to both applications in just a few clicks. Start by creating a new application firewall. give it a name and appropriate labels. Then select Enforcement Mode. The default is Monitoring. Blocking mode means that the WAF will take mitigation actions on the offending traffic. Next, select Detection Setting. Select Custom Detection Setting if you want to customize the policy detection defaults. The signature detection allows you to use different signature sets by accuracy. Automatic false positive suppression is a feature that we use machine learning to detect and automatically suppress security events that are the results of false positive. You can also enable or disable threat campaigns and disable various violation types. By default, all violation types are enabled. Next, we'll configure bot protection setting. The action taken for each of these categories can be customized. Finally, you may configure some advanced settings like allowed response codes. By default, all response codes are allowed by the WAF. We'll go ahead, click Save and Exit. The last step is to add this application firewall object to our existing load balancer. We go ahead to open the load balancer configuration of the DVWA app. Scroll down to the Web Application Firewall Config section. Select App Firewall and select corresponding App Firewall object we just created. Click Save and Exit. We go ahead to repeat the same steps for the Hipster Shop load balancer. Now that we have protection set up and deployed for both applications, let's really see them in action to test our WAF. Now what we are doing here is to rerun the same set of attacks as we did before. First with command injection. Then start cross-site scripting. This time, we are seeing the outcome is very different. All the attacks are blocked. We've successfully protected our applications. Moving on, let's explore some of the visibility and security insights provided by the F5 Distributed Cloud dashboard. From the main dashboard, we can drill down to an individual load balancer. We are showing our per load balancer security-centric dashboard. It's a single pane of glass with widgets that provides the overview of security events, signature hits, attack types, WAF policy events, etc. The Security Events tab provides a detailed list of WAF events along with supplemental information like request path, a method, source IP, etc. We can also drill down to see the very detailed information. The information part of the event contains source data like IP address and also the request data including parameters, method, etc. The detection part describes the event type, WAF action taken on this event, and also the list of signatures that have been detected, and important details like signature ID, attack types, and also the matching information that led to the signature being triggered. For more in-depth analysis and troubleshooting, you can also click on the JSON tab, which presents a raw event data in JSON or YAML formats. We also touched upon automatic false positive suppression feature to reduce false positive. We can also manually identify any false positives and create exclusion rule that would override WAF blocking action. To create the exclusion rule, we just go ahead, click the three dots next to the event identified as a false positive and select Create Exception Rule. Then click Apply when it's done. Excellent. Now you should have a good understanding of what F5 Distributed Cloud WAF can do for your OpenShift applications in multiple clouds. This concludes our demo. Thank you for watching.